Hello and welcome to Automation Talk. I want to thank everybody for coming in and joining us today for our Automation Talk show on motion control with micro PLCs. Now today, Mr. Tom Walowski is going to give the majority of the presentation. I'm sort of putting myself out of a job with all this fancy equipment and videos that we've got. So anyway, actually I'll help him out. We're going to show you basically what Automation Direct has to offer
as far as
product goes, maybe some solutions a little bit. Actually, Tom, I'm going to bring up when everybody signed up, you were able to maybe put some suggestions in, and I'm going to bring that up too, and we'll just sort of hit those as we go through. And several of them I know you had already basically accomplished with the little demos and whatnot. But Tom's got some pretty cool stuff he's got with the demos. But I'm going to hand it over to Tom and let him take off and show you what he's got.
Okay, our first slide, we'll bring it up. We'll cover a little bit about motion control in general. Next slide. Well, first of all, the products we're going to cover today and everything's going to include our Sure Servo, our Sure Step, and Sure Servo is basically our servo units. Sure Step is stepping motors. It's going to cover the motors, the amplifiers, the drivers, and the cables and all the other peripheral cable. Part of motion control also involves encoders. So we'll cover the different encoders we carry. That both includes incremental and absolute.
Mm-hmm.
We're also going to talk about our PLCs. They're an integral part of motion control from our end of it. And the reason for that is some of the smaller units actually have pulse output and high-speed count inputs that lend themselves to motion control type applications. Along with that, we also sell a couple of modules that are used with our PLCs, one of them being the C-Trent, or counter interface module. That's one of the, I don't want to call it older ones, that's specifically for the DL205 product line, but it still has a lot of applications. The one we're going to demonstrate today, we refer to it as C-Trent. That is our high-speed counter interface module. And then also, we don't have a demo on that. That's going to be in the future, so I'm kind of looking forward to setting up some other demos on motion control in regards to servos, but also in our line of Click and Productivity 3000 products, we can do ASCII outputs in our forms of both our Sure Servo and Sure Step, the high-end or the advanced Sure Step modules. They can actually accept ASCII commands, and we'll talk about that a little bit. Next slide, Shane. Let's talk about some of the motion control choices. Anytime you get into motion control, of course you can do pneumatics, which comprises of air, compressed air, to operate cylinders, grippers, and we also have a line of cylinders. We're not going to really talk about them today, but they're actually ideal for pick and place type applications, so they definitely would fall into the line of motion control. They're well suited for velocity control and programming position. Also in line with a fluid type thing such as compressed air, you also have hydraulic type controls. They're good for high power type applications. One of the downfalls on them is the potential for leaks, and then they generally require a lot of maintenance, and there's some environmental impacts that you'd have to worry about. One of the easiest to implement types of motion control is an electromechanical actuator. And basically with our servo motors and our stepping motors, we're able to take things like ball screws and different rotary type motion and apply them to those. The good part about it is, the steppers and servos, to power the actuator, gives you a kind of a, not a cheap, but a less costly type solution for motion control. Next slide, I think we're going to continue to talk about motion control choices. So with the electromechanical actuators such as ball screws, you can also do rotary motion. There's a lot of applications with cams and whatnot that the rotary motion lends itself. We can also do linear motion with the means of ball screws. What's the difference between servo or a stepper? system. Not to read the slide or anything, but servos generally do a couple things. One, they put you in the higher power type applications, or where you need more beef to get something done, but they also give you the potential for closing the loop as far as where the motor is, not necessarily where your slide or whatever you're trying to actuate. You'd need some kind of feedback device, such as an encoder or some kind of ultrasonic sensor. Stepping motors are going to be a little bit on the lower end, but the and they're open loop, meaning there's no real feedback. So one of the things in applying a stepping motor you need to make sure is you have enough power there, because the last thing you want to do is send it a stream of pulses, and we'll get into how we calculate some of that. But you get out to a certain point, you don't want it to stall, and you lose track of your pulses, and therefore you lose track of your position. Next slide. I think we're going to talk a little bit more about motion control and why you would use high-speed pulse outputs to a stepping motor. And one of the things is all the logic, the motion control, and everything else is part of the same application. The programming is accomplished with, and we'll see it here with relayed ladder logic that a lot of folks that have used these units are used to. And then the entire machine control, including operator interface, it's all integrated and easy to control. And in our demo, we will see that. The little diagram on that slide basically is showing a DL205 with a C3O module showing pulses out. But along with that, on our application, we can also control through the ladder logic not only what we want to do with the C3O to the stepping motor and the pulses out, but we can control other logic within our application, machine, or process. Next slide. Talk about applications real quick. This slide's showing high-speed cut to length. So basically, what you're doing, you're actually measuring, how far out you want to go, and then cut the length on the unit and everything. Next slide. And then we also have a high-speed time in the track. So in this case, we actually have some kind of gear placed on the drive pulley for the belt, and off of that we can actually count how many revolutions that pulley makes, and if we know the circumference, we can calculate the distance the belt runs, and off of those pulses we can actually tell where that product is. So if we sense it, we can actually count those pulses, high speed, and determine something. In this case, like maybe we want to stamp the product, or maybe we've sensed there's something wrong with it and we want it to go another a couple feet on the belt to a reject gate and actually reject the product off of the belt. Next slide. Oh, I'm sorry.
Or as we did 10 years ago, we were reading how fast the race car was going.
Oh, yep. I remember you telling me all about the sensors you put in the race car with the products.
Yeah, we were using high-speed counters before they actually came out. They were the prototypes. They were the beta types, and we were using them on the race car with RPMs and wheel speed.
Oh wow! Yeah. I wish I would have been here then. I would have loved doing that. Another application is actually taking a stepping motor, and because we can determine how many steps it takes to rotate something, we can actually gear it up to an index table or some kind of an assembly machine and actually index it to the different stations on the assembly machine. Finally, another application we can talk about is a drill transfer. Basically here we have a linear slide, and we're going to move our product into position and drill a hole. So we can drill a series of holes and move the product back and forth to get the location we need. Next slide, we want to start talking about the product. So for sure, we have Sure Servo. Yep. For sure. Does that make sense?
Sure.
And along with that, we have a total system, which would include the amplifier, the motor, and maybe we can point out some of the product over here. Here's Shane's got his hand on one of the larger servos, but
very light. Right?
Very light. But in this case, I can't even tell you the shaft diameter on that, but there are two plugs on there. The one plug is actually the power plug that gets the three-phase power into the motor, and the other plug is actually the feedback that goes back to the amplifier. One of the amplifiers is down there on the end. If you want to scan down over here, there's two of the Sure Servo amplifiers set next. By the way, they're available anything from 100 watts up to 3,000 watts. So there's a lot of, if you want to convert that to horsepower, I think horsepower is something like 756 watts to a horsepower, if I remember right. They do carry a 2-year warranty, and there is also software available from our website that allows you to actually size the servo for your application by plugging in, the numbers and everything. There's also a special website we have that we show on the slide, which is just www.sureserval.com, that has a lot of useful information for Sure Servals. One of our future demonstrations will actually set up some servos and come up with a way to show you how to program them and set them up. Next slide, I think we get into our Sure Step products. Back when we first released these products, I was actually on the documentation team, so I actually had the opportunity to write the manual for the first series of stepping motors and drives and power supplies. So the first one we came out with involved one driver. It was one power supply and you had a selection of 4 different NEMA type, the square platform, and if we scan over here, we can show a couple of our stepping motors, and then also the cables. We had a maximum 3.5 amps. They're dip switch configurable, and the micro stepping, that's the neat part. A typical stepping motor takes 200 pulses to make 1 revolution. If you micro step it, you can actually put multiple steps into it, so you get a finer movement out of it, and therefore with the micro stepping we can do 2 times, 5 times, 10 times, or 50 times. If you do 50 times, instead of taking 200 steps to make 1 revolution, it would take 10,000 steps to make that same revolution. By increasing the number of steps, and I'll explain that a little in the demo, what happens there, you actually pull down the speed, because with the C3O card we can go up to 25 kilohertz output pulses. So if it takes more pulses to make a revolution, and I can only go so fast, I'm not going to have max speed. So there's always a trade-off. And we can also, we'll talk about the self-test feature and then aisle current. Since this line of product came out, we recently, in the past year, I think it's been a year now, we came out with the next slide will show the advanced Sure Step. And here we're offering 3 additional power supplies, 2 additional drivers, and an additional 5 motors. And these are higher torque, or we call them super high, not torque, I'm sorry, higher output, and in our case we're calling them super high. With these, the actual driver is programmable, and the software to program this unit is free. You can download that, and actually we show one of these over here in the product side. We want to jump over here. Shane has in his hand. Okay, there's a little disc that comes with it with the software, but you can also download that software, from our website. And there's also, each of the drivers comes with a programming cable, which is convenient. So we offer 3 different drivers, 9 different motors, and 4 different power supplies. And the high output versus the super high, there are actually 2 different cables for those, and the mating connector on the stepping motor will actually, you can't interchange them. Next slide, we get into encoders. Not a whole lot I can say about the encoders, but on the incremental side, we offer a light duty, a medium duty, and a heavy duty. The ranges are everything from something like 10 pulses per revolution up to 3,000 pulses per revolution. The medium and heavy duty are IP65 rated, light duty is IP40. We also offer an absolute encoder, and basically the absolute encoder is going to give you a multiple binary pattern that tells you the position of the encoder versus just pulses. And encoders typically have an A channel and a B channel and a Z channel. So if I got 2,000 pulses coming out, I'm going to have, on the A channel and B channel, I'm going to have 2,000 pulses. They're going to be 90 degrees out of phase, if you want to look at it that way. And then the marker pulse, the Z channel, you're going to get 1 marker pulse every revolution that tells you how many revolutions, if you want to keep track of them, you've made. Next slide, we're going to talk about, yes, sir.
The Koyo encoders, real quick. Koyo is known for three main things: is Koyo Electronics, which is our PLCs and automation equipment, Koyo encoders, and also Koyo bearings. But yeah, Koyo's make some really nice encoders.
I can't contest to this. At one time, I think they were the most popular. I mean, I still remember way back when working on CNC machines, and the machine would break down. We'd have to tear apart the drives on them and everything, and we'd end up finding a Koyo encoder, buried in there that was keeping track of the revolutions for us, or the positioning, I should say. We can't forget our PLCs. They're an integral part of the motion control that we offer. In the micro end, guess what I want to say is, with the micro units here, we have the DL05, which we're going to demonstrate, the DL06 and the DL105. All three of these, without adding anything else, actually have high-speed counting and pulse output built right into them.
If you get the DC models, right?
DC models, yes, I'm sorry. That's very important. They have to be DC in, DC out. You can actually, if you just get DC in, you can still do high-speed counting input, or if you just get DC out, you can still do pulse output. I didn't get into detail, but I think the 105, there's one channel. The 05 and the 06, I think there's 2 or 3 channels. In the back of my mind, I think the 05 is limited to 5 kilohertz. The 06 might be 10 kilohertz. We'd have to look them up to be exact, but that is an important factor to look at if you're going to choose to use the built-in modes for controlling stepping motors or taking encoder pulse inputs and keeping track of the position of something. Next slide, we get specifically into those modes that we were just talking about. So on the DL5, 06, and 105, we have mode 10's high-speed count. Mode 20, the quadrature, is actually where you're taking the A and B channels from the encoder. Pulse output is basically if you were going to try to drive a stepping motor, and you'll get both your direction and step pulses when using mode 30. It takes some programming and ladder logic to actually initiate these modes. High-speed interrupt is exactly what it says. I want a pulse to come along, and even though my PLC is sitting there and scanning, my high-speed interrupt is going to take and jump it out of the program and go take care of business or whatever it is. Pulse catch, typically a DC input on a PLC. If you see a pulse much shorter than a millisecond or whatever, you could miss it because it maybe didn't fall in the right part of the scan. With the pulse catch, it actually remembers you had a pulse there and updates the scan. And then filtered input allows you to, especially like motion control or something where you're trying to look for different signals and eliminate bounce, it actually allows you to filter out that bounce and get a clean signal into the PLC. Next slide, I think we actually start into our demo. So in this slide, what you see is actually there is a DL205 PLC with a C-Trio module that produces step and direction signals. We actually are going to use a DL05 because it's small and less expensive, but we're going to use an H0. Shane has one in his hand. We're going to use an H0 C-Trio module. The pulse and direction are going to be wired into our driver, and then from the driver with its power supply, we're going to power the stepping motor and actually control it. In our case, in the demo, I probably won't hit too much on it, but as you can see over here, that's on this slide, is actually, let me point this out, up here in the, right here is our DL05, here's our C-Trio card, there's some terminal blocks, a little power supply you use to power the Seymour Micro, and then down below you can actually see the power supply, and then over here is the actual driver card with dip switches on it. And out front here is our ball screw slide, coupled up to a NEMA 23 Sure Step stepping motor. There's actually a Helix coupler that we're using to go from the 1/4-inch shaft Actually, it's 8 millimeters. Sorry about that. To the shaft on the ball screw. The little contraption we have here, we're going to try to demonstrate different moves with trapezoid and S-curve type moves when we get to it. And if you pan over here to the Seymour, on the Seymour we actually just used it as our interface. So we're going to use it to jog home and actually execute 2 different moves with S-curve and trapezoid. So the next slide is going to show us one of the important things, and I always get tripped up by this, is on the C3O card you have to determine whether you want sourcing. If you work with any kind of DC output or DC inputs, we always talk about sync, source, and basically you might get into the difference between PNP and NPN transistors and drivers and whether the current's being sourced or sank. So one of the important things, this card, the H0C3O card, typically comes in the comes in the source and output. The jumpers are in the source, and it always trips me out because I'm used to wiring stuff syncing, so I get everything hooked up, doesn't work.
Forget the default.
Forgot to change the jumper. So don't let that trip you out. Make sure you look through the manual and get to the different jumpers and determine how you want to set it up. And the next slide, I think we show our dip switches. So the second thing that trips me up sometime is forgetting to set the dip switches. So if you look at your driver card, now your advanced stepper cards, you can actually program all of this through the software. Right. On the first original driver we came up, there's a 9-position dip switch. Switch 1 is the self-test. So if I put that in the on position, my motor or my driver will actually set and change the direction back and forth while it's putting out pulses. Right. I forget it, maybe it's 100 pulses in each direction. Switch 2 and 3 actually allow me to set my micro stepping. In my case, I went with 2,000 steps per rev, which is called 1/10 or times 10. So my 200 times 10 means it takes 2,000 pulses to make revolution, but I also have the choices of 400, 1,000, or all the way up to 10,000. Switch 4 allows me to either have no current reduction or I can have idle current reduction. Anytime we can save power, reduce the amount of heat is going to add to the longevity of any type of electrical or electronic equipment. So the factory default on that is a 50% idle. So anytime that motor's sitting there and nothing's happening. Now you may, in some applications, if you're trying to use the stepping motor when it's in a stop position to try to hold something, you might want to not put it in reduced current. You want more current to lock the coils in on it so it doesn't move. And then finally, switch positions 5 through 9 allow me to set the current. So I end up looking at my stepping motor, and on the nameplate on the stepping motor is going to be my current. In my case, I'm using a STP-MTR-23079 motor, and it's rated at 2.8 amps. There's already a base current of 0.4, so in my case, I actually have switches 8 and 9 in the on position, which takes 0.4 plus 0.8 plus 1.8. If you add that all up, it's 2.8 amps. Next slide should show our little wiring diagram. Basically, we have the DL05,
which is a small unit, and then the C3O is even smaller.
And out of it, there's a Y0 and Y1 output, and I should warn everybody that Y0 and Y1 has nothing to do with the normal the real world. So you're on your PLC, you still have Y0 and Y1 as outputs. So those are just the designations that's out of that C3O card. And there's also a common, so if you looked at that real close, I'm actually taking 5 volts out of my power supply, running that into the common, and then my 2 signals for step and direction run down into the actual driver card, and then the common side of the power supply goes to the common on the driver. And then there's also 35 volts DC that is used to provide power to the motor, so those 2 wires are running down to the driver card, and then This is a bipolar stepping motor. That's all we sell are bipolar. That takes 4 wires to get to the 8 or 4 coils that's inside the stepping motors, and actually a nice little illustrations in the manual that explain how that stepping motor works. And we also show the stepping motor and the color code.
Now you're showing stepping motors and all this stuff. I have to just ask,
Sure.
because questions are coming in a little bit. I don't want to forget, but is it any harder to set up a servo than it is a step, or is it vice versa, or is it about the same?
So servos are going to take a little more to set up because there's more programming, more things you have to take into consideration. There's more wiring. You know,
Right.
we're talking 3-phase, although some of the smaller servos will handle single phase. But you have 3-phase. There's, you know, both a power cable that goes to the motor, and there's also the feedback cable. So you have to take that into consideration. And then there's a little more to do with how you want to control it, because I can control the servo with ASCII commands if I'd like through an RS, I think it's 232 or 485 interface.
So you can still use the high-speed counter as well to control it, or you only use ASCII?
We can use the high-speed counter to actually have it accept pulses, or we can do ASCII, or we can do, you know, voltage input to it. I hope that, you know, if that doesn't answer the question.
No.
Yell
I'm
at
just,
us. We'll
some
get you
of them
more.
are. I'm letting them get away, and I don't want to forget them.
Yeah, because if we don't answer, you yell at us, please, because, you know, our main concern for being up here is to help you understand our equipment and get you to use it, but also to make sure we answer all your questions or get you some kind of answer. If we can't answer it, we'll find somebody that can. So our next slide, after we get our wiring done, we're going to have to start programming. So the very first thing, if we want to switch over to the software screen and everything, and as the slide shows, the first thing I want to do is, and I tried to comment this the best I could, but we have iBoxes within the DirectLogic 5 software
Right.
that we didn't have until a couple years ago. And there are actually a special series of iBoxes primarily to be used with the C3O card. So the first thing I need to do is configure that card. And if you look at what I'm looking at here, the C3O config, it's IB1000 box. I'm going to tell it what C3O number I want. Default's K0, so I'm going to use K0. And in the case of the DL05, that card is physically in slot K1.
It only has one slot in it.
Only
Now,
one slot.
if you were to use an 06, you could have 4 of these in there.
That's correct. Yep. Actually, I have an application I've been working on for a year now where I have 2 of them in a DL06 that I'm trying to play with. But we need to assign a vMemory address, as you can see here, and I randomly select V2300. But then we also need to tell where the input and the output information is going to be, and those are down here in V2400, and the output is parameter 3, which is actually something we can control. If you go to the next slide, once we set that up, the next thing we need to do, there's a utility, if you look back on the screen, up here called C3O Workbench 2 for DirectLogic PLC. That WB2 is its version 2 of Workbench. Workbench is actually this, part of the software that our Federation partner host develops, for the DirectLogic PLCs, and a lot of the utilities and everything for the C3O card and some of the other peripherals that can be added to it come from them. So I'm going to open my Workbench. If we go to the next slide, I'm going to select the link. In my case, I'm calling it DL05 Motion Control with Micro PLC, the name of our webinar today. And this takes a couple minutes. It's actually going through the same communications that we're using the ladder logic to communicate with. And like I said, it takes a second or two. So what you're seeing right now, eventually we should see an active screen that allows us to configure the C3O card both in memory usage and the I/O usage, and then also tables. I know you can't see everything, so I'm going to move this around a little bit, but we actually were able to give it a name. We know what comm link we came on. We know right now it's on, and we have in base 0, which is the DL05, in slot 1 we have a card we could rescan if we needed to. And up here we have our current module. We can give it name and some descriptions, and we'll talk about a little bit about here. You can check the actual firmware version to make sure that gets updated. And also, if I can get down here, we also have our I/O map we'll talk about, and then we configure our I/O, and then the main thing we want to talk about is we can actually go in here and set up a bunch of move profiles that we did in our case. So if you go to the next slide, I think we start talking about the I/O map, so we'll jump there. And this is going to be hard to see. Let me pull this down. For the DL05, I'm going to use 2 ranges. So for my input map, I needed to check enable write. I randomly used V2400. And then over here in my output, I checked that box and I used 2330. Now the reason I went up to 30 is I knew 25, or actually 26 V-memory registers were going to be reserved for the input, and I'm not sure what 30 is. Looks like that's about 32 are actually used for the output. So if you go to the next slide, once we have that set up, we can look at our output features, and this actually takes and tells us all the different parameters that are assigned to the different bits and memory locations that we assign. So we can look at, if our output's selected, we can enable the output. We can basically control everything in that C3O card that's going to control the pulses and steps, or steps in direction that goes to the driver card to the stepping motor. And then finally, the next slide, in our system function, we can actually look at the various V-memory locations that were assigned to the different channels that come into the C3O card. And I can tell you right up front, I'm using channel C as my homing sensor, but I can also look at output 0 in my case is actually the steps and direction that come out of the module. So once we have that all assigned, you go back to here, we can see the I/O map. The input starts at V2400 and the outputs start at V2430, if I said that correctly. Then what's our next slide? I think and I should say I kind of jumped ahead. This slide's kind of out of place, but it has to do with the I/O. Once I have everything set up, and if I wanted to test this unit, I can go to Monitor I/O, and it's going to tell me if I go here, it's going to disable the actual output, which is okay. That's okay, fine. I want it disabled anyway. If I move this around, I can actually sit here, and I can go to right now I'm on my I/O status and input function. So like I know I'm using C, so if I went out here and triggered my proximity that tells me I'm homed, I would see this come on. And right now, out 0, out 1, out 0, I'm not even sure. One's the direction, out 1's the direction, and the pulse output's actually out 0. If I go to my output function, I literally can take the different velocity modes, or I can load one of my tables we're going to talk about here in a second, and I can actually execute it from this I/O monitor mode. I can process the command, I can change the direction, and if I wanted to, I could enable that output and actually have the stepping motor move. But since we're already homed and coupled, I don't want to do that at this point. But just so you know, you can use the C3O workbench to actually test your unit. And now that we're back in, it's saying, hey, would you like to re-enable everything? Sure, I want everything back up and good. The last thing we want to look at here, if you go to the next slide, is we want to look at our pulse profiles. We have 4 of them. As you can see, we have homing, dynamic velocity, a trapezoid move, and an S-curve move. Let me pull this down in here. So real quick, if we go to the next slide, we can do edit. I've already set these up. I'm sorry, Shane, I had you jump ahead too quick. Yeah, and in my case, I wanted to do a home search. I'm calling it file number 1. And in my case, I want to run, if you can read that, to limit 1, which is actually coming in on, down here you can see it's coming in on channel 1C, which is physically wired to the C channel on the front of that C3O card. I want a high level, and then I want this thing to seek that switch and run at 7,500 hertz, and once it hits the switch, I want it to reverse directions, and that's in this selection I made up here, and move at 1,000 hertz for a count of 2,000. And in my case, 2,000 happens to be 1 revolution. So that gives us our homing. And if you go to the next slide, we'll talk a little bit about dynamic velocity. And we're actually using this, and actually this was the default, so I didn't change anything. And what dynamic velocity does is, as we accelerate or decel in either the clockwise or counterclockwise thing, we're going to get 10,000 pulses per second. So it actually ramps up, but there's a limit, so it's eventually going to reach its limit and not stop. But I'm actually using dynamic velocity to jog the axes back and forth. And there's probably other ways to do it, but for me this was the simplest. And then finally, if you go to the next slide, we'll look at the trapezoid. And here, if we could get that over here, trapezoid, we're allowed to tell the total pulses, and I can tell you I used 160,000 pulses. And if you do the calculations and everything, the pitch on the ball screw I'm using is 0.125 or 1/8 of an inch per rev. So it takes 8 turns to move 1 inch. And I wanted to move 10 inches, so that's basically 2,000 per rev times 2,000 times 8, 16,000 times 10 inches is 160,000 pulses. So if we go back and look at the trapezoid, we have an acceleration time of 50 milliseconds, a decel time of 50, our start frequencies at 100, and our max frequency output is 2,500. So that's going to give us a trapezoid. I actually cut these times down because I was trying an experiment here. I didn't want to stall the motor. If you try to run at 25,000 hertz and you have this set up too fast, you're actually going to, if the load's too great, you're going to stall the motor. So I wanted to get this to kind of give me a jerk to try to show you something. I'm not sure it's going to work, but we'll test it. If you go to the next slide, and then the other one, it's pretty cool that we have programmed in. And again, we're going 10 inches, so we got 160,000 pulses. We have a real slow accel and a real long decel time. We're going to start way down, but we're going to try to reach 25,000 hertz. But this gives us a real nice smooth ramp up and ramp down. And what's our next slide? So we have 4 profiles we've put into the unit. And before we test it, let's go back to our ladder logic. So I'm going to quit out of Workbench. So we're done with Workbench. So again, to recap real quick, in Workbench, we actually set up the memory, the I/O map. We configured the I/O. I'm not sure I showed you that. Let's see. I don't think I showed you the, there we go. Did we show this? Where we actually selected, over here on the outputs, we wanted the first 2 channels to be pulse, stepping out, and then down here under channel C, we wanted that to be a local output. Anyway, I don't think I showed that, but you need to set your, besides configuring the I/O, you need to set that. Maybe we did do that. Sorry. If we did, won't hurt to, because I always forget, won't hurt to remember. So we quit that, and we go back to DirectSoft, and now we kind of get into a repetitive thing. So if we look at the next slide, this is another iBox instruction under, whoops, I jumped you ahead. Back up one. There we go. with this, we're going to actually load the profile. So if you look at the software, again, my C3O number is K0 or 0. The output is 0, and the file number that I want to load up is that first file, which is the homing file. And I still have to assign a workspace vMemory, and it has to be, doesn't have to be specific, but it has to be only used in this instruction. You can't use it anyplace else. And I have a couple flag bits down here that tells me whether this loaded properly, called success and error. And then the next slide, I threw in a little bit of ladder logic. If I can get this down here. Oops, got to close this up. So if I slide down a little bit, I'm not sure we're going to see that. Did that help any? Okay, I'll just move it around.
Oh, we got it on the slide as
well.
well,
It's on the slide too. But what we have here is we're actually looking to make sure that that load profile was successful. There was no errors. Also, there's a push button on the Seymour panel, the C0. When we push it, we're going to get a signal. And as long as channel 1 is not active and we don't have any axis over travels, we actually have a couple sensors on the back of our ball screw here there are proximities, and there's some metal targets on the slide that actually tell it if it's over travel in either the left or right condition. But if all this is good, we're going to get an output. We're going to reset our direction, and we're going to lock that in, and it's going to take place as long as that profile move is active. Once it's done active, it's going to reset this whole circuit. So I'm not sure the audience is seeing all this. I guess it is on the slide. So that was it on that part. The next slide should get us into information, but we're going to switch over here and give you a live demo now. So you'll have to forgive me if show them the Seymour real quick. On the Seymour, we call it motion control. I have a jog left, jog right, a home button, trapezoid move, and then my S-curve move. So I'm going to turn this, and if you want to go back over the slide, I need to turn it so I can see it. And if you go back to our actual slide over here with this is just an unbalanced weight made out of wood we have on here to try to show some stuff. But I can actually take and jog this left. And Shane, I don't know if you want to hear the stepping motor move, but
yeah, I have to do that. I have to do this.
Shane's going to put his mic down here so you can hear some of the harmonics that come out of the different frequencies. But basically, I've jogged to the left, and now I'm going to home it. And you'll notice my jog speed's a little bit different than my homing speed. That's intentional. And if you can see that, there's a little metal tag that's going to hit that little rectangular proximity. You probably hopefully you saw a little red light flicker. So that was jogging, that was homing. So that basically was file number 1 and file number 2. The next thing we're going to do is an S-curve. This is pretty cool, and we've over-exaggerated, the ramp up, ramp down, or the accel, decel time and everything, just to there's some harmonics in there. The whole table was shaking here. But if I had a tape measure out here, that would be exactly 10 inches. I'm going to home it. And then our final move is going to be our trapezoideo. And what I was hoping here is, because it's so aggressive in the accel or the decel, that my little wooden unbalanced weight up there would, it would show it falling off. It may or it may not happen. There we go. So that move was a little aggressive. We could actually take the 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 Excel decel time and take and increase it, and we would eliminate that. And then finally, I wanted to show we have over travels proximity. So I know you might not be able to hear this, but on the Seymour, I actually programmed in some alarm messages. So my screen's back here blinking, and it's telling me, hey, you over traveled to the left. So now I can jog off of that over travel. Now I can rehome it, get back to home. Hopefully this is giving you a little bit of a idea of how quick and easy that you could take our stepping motor products with something as simple as the DL05 and the C3O module. And again, you can do the same thing with a top speed limitation by just using the mode 30 output from the DL05. Make sure you have a DC output from the actual DL05, as Shane pointed out earlier. So that pretty much wraps up the demo, wraps up the product line. We hope to follow up with this at some time in the near future with more information and demos on the other product lines like the Sure Servos, and try to show you some applications where you'd actually use the encoders and some of the other modes from the PLCs.
Well, Tom, let's talk about real quick. We had our slide was on information resources, and I'm just going to mention that, and then we're going to go straight into Q&A.
Okay.
Don't worry about jotting down all these information resources. It's just about the Sure Servos and C3O and stuff like that. But we'll send that to you in a thank you email after the seminar.
Most of these are, and this is just part of the application notes. There's a ton of application notes in regards to Sure Servo with our different PLCs and how to use them. And everything.
No application notes that you have, or these are ones that our tech support puts out on their website?
I'm sorry, I apologize. They're the ones that are on the tech support website.
You'd mentioned earlier about, like, say, for instance, the iBoxes, which are the intelligent boxes in DirectSoft 5, with the CTRIO. I think Bruce Perry over in tech support and I had done a webinar on that.
And that's up on the AutomationTalk.
Yeah, that's on AutomationTalk, or actually it might be on Learn, I forget, but it's on one of them. I'm pretty sure we did have it on Learn as well. But yeah, we've broken some of what you've done today. We've broken little bits and pieces and had it in some other seminars. But yeah, that was a pretty good one. All right, we're going to stop and go ahead and take Q&A because we're running over, and we've had a couple of good questions here. First of all, Mr. Knight here, he's from an educational university, and usually has a pretty good class, and they're watching these, and we love that these guys come in here and watch, so we welcome them anytime. But they're saying they've used the Sure Servo and similar units from other manufacturers. The question is has the Sure Servo been added in the last 2 or 3 years? Is there programming that's being put in it, like the stepper drives? Are we going to improve anything there? Another question he's got on there is also, can it now do registration, meaning can it change position or velocity set point on the fly?
There's actually an app note that talks about using the Sure Servo to change registration.
Okay.
I ran across that, and actually there's been a couple new app notes as far as any changes in the equipment, the programming software. I'm really not aware of it. I know the Sure Servo's been around for 2 or 3 years, but
right.
We haven't extended the product line. I'm not even sure there's been any like firmware updates or anything on that particular line. But
yeah, well, I think when we came out with these, we actually went out and looked at of course, we don't have the full spectrum. What our product managers typically do is they're going to look and see what's the biggest sellers, what is the industry looking for, right. And that's what we're trying to target, so we can get those products to you as quickly as possible, as cheap as possible from us. That way we can be the one-stop shop. And no, Mr. Knight, it's not too detailed to ask that question. No, that was a pretty good question, so
good
thank
question.
you. Yeah. Another one, we could have hit this one in the very beginning when Tom was talking about the 06, the 105, and the 05, and customer has a good question, is will the Click PLC be able to run the steppers or the servos? Now,
Currently, the click, the easy answer for that is yes, it can actually run the advanced steppers by way of there's actually an app note on that out on the tech site, but it can run it by using the SCL commands, and we kind of glossed over that. We didn't talk about that. We're hoping, or we will have another webinar where we'll specifically take something like the click with the advanced stepper driver, and we'll actually use the ASCII commands, the SCL language, and talk to the click, and we'll set up the same demo probably with the same slide. We'll probably use the same motor. I mean, we can change motors up too and everything.
Yeah, so keep your eyes open. Tom's going to do some more demo.
And then on the Sure Servo, there's that first app note that's in that reference that Shane will put in the email to you. There's actually a app note. It's like 16 pages that goes through all the detail and everything to take the Sure Servo from the Productivity 3000, and I think there's an additional one in there. It talks a little bit about click, where you can actually take the output from the Productivity 3000, the RS-232 port, or even maybe the 485, and take ASCII commands and spit them out through the instructions within it, and actually set up different motions and profiles and everything.
I think to answer the second part of that question is and I might get shot for this, but yeah, any of our new products that we come out with, a lot of times we're trying to get them out to our customers because we've got certain, you can't develop a product in its entirety and then get it out, or it's going to be out of date. So yeah, and sometimes we have to release a new product without all the modules and all the features, even though they're still in the list. A lot of them have been in the works for a couple of years. So yeah, keep your eyes open on the Click and the P3000 because they are going to have some high-speed stuff coming out. So
definitely.
Couple more questions, and I really like these, so keep throwing them out there if you've got any. How hard is it to set up for jogging a stepper?
As you saw right here, it took me, I threw in, in the ladder logic, I threw in, configure the C3O, and then the next thing I did was created the workbench with a velocity command, and I used a couple contacts and everything out of my Seymour Micro to actually jog it back and forth. I mean, it took very little programming. It took me longer to wire everything up than it did programming.
Sure.
So it's very simple.
Next question, is the Sure Servos available in 480 volt?
Not at this time as far as I know.
Yeah, I don't think so either.
I don't have the website up.
Yeah, we can go out to the website and take a look at that and let you know. But yeah, I'm almost positive we don't. Let me scroll through and make sure that, like I said, when you register for the event, you can throw in some requests. Controlling servo with Click PLC, we hit on that. Direct soft programming, just general information. A lot of customers are putting out their applications, just have some questions about their particular applications. It gets a little tough. Indexing operations.
Yeah, those type of questions, I mean, if you're getting specifically into an application and you started down the road to do the application and you're trying to figure something out or how to do it, those are best, and that's why our tech service is there. That's why it's rated number one, and it's free. I mean, they're more than glad to sit there and try to, help you with your application as far as, how to do different stuff with the products. They won't necessarily do your application for you, but they'll tell you, what the equipment is capable of. And
well, and any time that you do have an application, you feel that you might be over your head, you can always go to our website, or you can call our tech support, and they can give you some suggestions. Of we have either VARs that can help you with it and do the projects for you, or we have
system integrators?
Yeah, system integrators. My mind went blank. But we do have a list of system integrators that they have to meet certain criteria for us to list them on our website. But yeah, we have some really good system integrators out there. I'm going to hit the last one here, and then if there's no more Q&A, we're going to go ahead and wrap up. Next one, somebody asked, I think this is more towards their application, but they're saying, can you do, multiple axis? Yeah, I mean, if you had two of those, obviously, and you couldn't do it with an 05 because you only have one slot in it, but say an 06, well, you're $199 for an 06, pick up 2 CTRO cards, and you've got, you know.
Yeah, the main thing, keep in the back of your mind, you really can't, because of timing and everything, do coordinated, 2-axis moves. But like pick and place type applications where you have 2 slides and one moves this slide down here and whatever. But if you're trying to, draw a circle or something with 2 axes, that's not going to work very well with the current equipment here.
All right, last question of the day, lucky winner here. What is the capacity of the 205, say with a 260 processor, and how many axis of motion can it control?
That came up once before, and I don't know if I ever
Never looked at the max on. I know a lot of things we look at max. Say
power budget comes into that. I know that.
Yeah.
So you're kind of limited to power budget. I think if you really want maximum on drives, I think I think 16's the max, but you're looking at a 405 if I remember correctly. That sound right, engineers?
The guys behind the camera know about the products just as well as we do. All right. Yeah, we'll take. Let's tell you what. We'll take a look at that one, and we'll actually. This is another educational login here, so we'll take a look at that one. We'll actually email you and let you know because we don't know offhand. Yeah, some of them, like I said, you just got to figure out power budget, especially on the 205 stuff. You did have power budget limitations. You did have some slot limitations, and but the CTRO might do a little bit more because it's a little bit bigger. Right. Keep in mind with stuff like the P3000. Tom and I are working on a lot of videos. There's no power budget restrictions and there's no slot restrictions. So when we do come out with the high-speed cards, you can just pack as many as you can get in a base.
Exactly. Yeah.
All right, we're going to go ahead and wrap up. Like I said, thank you for all the Q&A. If we did not answer your question, we'll send it to you in an email. I've got all these saved. So pretty much this is the end of the show. Thanks, Tom, for doing the good demos there. He spends a lot of time. I think he spent a lot of time in his basement creating this one while he had some time off. But, yeah, he does an awesome job with the demos. But I get the engineers to go ahead and roll the end stuff. And thanks, everybody. And
thanks, everyone.
Have a great day.